So this talk's going to be about DBT. We've had several talks about DBT. This is going to focus on essentially DBT and the DBT scaling out, across the enterprise. We're going to do a little introduction about our company, what and why of DBT, how DBT is used, considerations for project scaling. We'll go into a little bit of the security architecture. And then the key demo is going to be around kind of a shared and a child repo in shared and child repo in DBT that enables you to scale out. And we'll talk about different kind of considerations on basically how different companies can use that capability to scale DBT out, like if they want to have it for multiple teams. We'll talk about sources, then we'll jump into a demo. So SEA Consulting, we're a technical staffing and recruiting firm, kind of focus on testing and evaluation of technical talent, specifically in the BI and analytics space around data engineers, analytics engineers, data scientists, data visualization. Kind of that's what we do. So what and why of DBT? So DBT is basically the T in the ELT. It's focused on the transformation layer. So it's not, as we've said in previous sessions, it's not basically about bringing data in to your warehouse, but once the data gets there, how to transform it. And kind of the primary method it does it with is, you create select statements. So most analytics engineers are writing select statements in their kind of daily work. Those select statements are then materialized in different ways. So either as tables, views, ephemerals, which are more like CTEs, or incremental loads, where you have two tables, a source table and target table. You look at data from one table using some field, either a date field, and you load another table. And that's kind of the core thing. So when you think DBT, you think about using select statements to materialize objects, and that's what essentially DBT does. And it's in that middle layer where you're kind of writing queries against your data warehouse. So considerations for DBT scale out. So organizations, as they're kind of exploring DBT as a tool, right? So one of the key things, that they look at is if you have a data warehouse, you want to use the compute power of your data warehouse, right? So because it does select statements, it throws those select statements to your data warehouse, and then that data warehouse runs them using its compute power. So DBT is, in a sense, it's kind of lightweight because it's basically a way to save. It does more than that, but it's a way to save your select statements and kind of push them down to your data warehouse to run. So when organizations are evaluating it for the analytics engineers, typically, they'll do a POC, and maybe if they like it, a single team starts using it to build out their projects. Now, when you want to scale it out and multiple teams want to use it, so they want to use it basically as a platform for their analytics engineering kind of users and developers. They want to use it across teams, and you want one single tool that you want to support your team to support for all the teams that are going to be doing analytics engineering work. Things get a little tricky, as we'll discuss, when you're trying to scale it out. So key questions that come up around DBT are like, how many accounts are you going to have? So what is an account? Basically, an account is like a subscription in Azure, if you will, where kind of the billing is against that one account. So it's like the most top level hierarchy in a DBT kind of service. When you take the service, that's the top level hierarchy, you get an account, and under that account you have projects. So This is important, like who's going to pay for it. If teams want to share one account and then they have multiple projects in that account, your team can discuss, it's a decision point will be, how many accounts do you want? In my example, during this demo, I'm going to show one account and we're going to show multiple projects, right? So in the subsequent slides, we'll talk about, some of the things that come up, who will manage the account level administration, because when you've got an account, you've got administration there, and then you have individual projects underneath that account, which is where the development is happening. Who's going to manage that? How many developers you're going to have? So these are issues related to your team that you will have to kind of go through to determine your kind of final architecture. I'm making some assumptions. Like I said, I've got one account. There's going to be a centrally managed account, and there's going to be a centrally managed project, and then there's going to be multiple teams that are going to have their individual projects, which we'll talk about. How many users are going to have read-only accounts? For example, if you've got users that want, DBT, when you're writing, one of the kind of key things or cool things about DBT is the documents that it generates, based off of the select statements that you're writing. That's a very, very neat feature. Those statements then, and the documentation you have read-only accounts, so how many users are going to be involved there? So with that, we'll talk a little bit more about the security architecture. So there's, as I mentioned, there's the certain, when you're talking about security within DBT and administration within DBT, you're going to have account level administration, then you're going to have project level administration. So then, within account level, you obviously have the account admin that kind of sets everything up. And then you've got administrative kind of permission sets associated with that account and with the projects that the projects underneath that. So with that account, and if, let's say you have one account and you've got project A, there's going to be the account admin and then a project A admin that are going to be able to do certain things. So for example, you have the account level at the top level, and then, you create a project. Then within that project, you have a project admin. And then within that project admin, you may have a person who's an administrator of the Git repo that project is tied to. It's going to be a user that determines which teams kind of come on board onto that project. And then below that, you've got your, your developer, kind of developer roles. Obviously, all the database administration and the connections to your kind of the warehouse, that they're project level settings, but they're managed by a project level admin. And then you've got the individual project level developers that are actually going to be developing within the tool. There's going to be permissions associated with that. So, and as I also mentioned, there can be read-only licenses, so that certain consumers that are only going to be requiring read-only licenses to read off of their the documentation or read information about the models. They're going to be in like a separate group, but they're managed at the account level, and then those read-onlys are also managed at the project level. So there's more information about kind of these settings here. But what we're going to talk about, in this scenario, as I mentioned, we're going to have like one account. We're going to have within this setting, we're going to have two separate projects. We're going to have one account and two separate projects, and each of those projects is going to have their own administration, but we'll work off of one account. So what's our setup going to look like? All right, we're going to have a team repository and with a shared repository. So in our project, we're going to have a parent. We're using GitHub, and we're going to have a parent repository. And that parent repository, so when you are building models and you've got select statements, and you've got macros that you develop. One of the things with macros is you have to write it in Jinja, right? So, and also with models, there might be some models that are shared across teams. So things like customer or, the organization hierarchy, locations, those are kind of usually data sets that are used by multiple teams, your marketing team, finance team, and so on. And that logic typically doesn't change, or you want it centrally managed, right? So each team, marketing, finance, and so on, the sales team have their own customer query and customer model, that select statement that they're writing. You probably don't want that. You want a shared location. So that setup is kind of what that setup is actually when we talk about supporting multiple teams, and kind of a key factor of scaling out DBT is that, right? Like, I want the models that are shared across teams. I want those in one location. I don't want different teams kind of reinventing the wheel every time they need to kind of query customer data. I want it in one location. Then also with macros, and macros are basically kind of like closest thing would be like maybe a stored procedure where they perform some functionality, right, that affects the behavior of your project. So there are certain macros, and we'll talk about the get schema names and how schemas are created in DBT, that the default behavior that DBT has, you probably don't want that working for all your projects. You probably want to force some standard version of this macro that everybody uses. So in this case, in this demo, I'll show that kind of functionality. We'll show like a model in a parent repo and a macro in a parent repo, and then we'll have a child repo, which is going to be indicative of different teams that are using, they're going to be using those objects in the parent repo, and they may have like different fact tables or other models or queries that are linked back to the information that's in the shared repository, or they may or may not have macros. And I think that's one of the things with kind of a lot of data teams. They may or may not have folks that understand Jinja or Python, but they will know SQL, right? So teams, depending on the kind of the decision makers and their kind of team structure that you're looking at, you may not want the macro and the complexity of the macro to do certain things to be left up to the individual teams, right? Because maybe they're just in the domain of SQL. So those activities you can have at the parent level, and then share that information via a parent repo connected to a child repo, to get that logic out so they can reuse it, right? So if individual teams like a market, if they have folks that that want to write their own macros, that's well and good, but certain things that can be shared, you want to have that in the parent repo and then have those be used across. So in this diagram on the left side, I'm showing GitHub. Basically, I'm going to show, you've got your repositories in GitHub, and then we're going to show bringing those into an actual DBT project, where these are two separate repositories in GitHub, and we're going to show the functionality where, via packages, we're going to run DBT teps, point to the parent repo and child repo, and bring those into one DBT project. And this project is primarily going to be connected to the child repo, but we'll bring in the shared models through the parent repo. So that's one thing we're going to talk about. Another thing that I'm going to mention are sources. So, and this is not really like directly related in terms of that child and parent repo architecture per se. But when you're here in this model, you've got models with customer, location, or whatever. when we say model in DBT, as I said in this slide, models are really select statements, right? And when you run select statements in DBT, it runs those select statements and it creates those objects. So in this case, if I do a project run, even though these are shared objects that are in my parent repo that I'm bringing in, if I do a run, it will run those select statements that are in my model. So one of the things I'm going to show sources, that functionalities, if you want to track data lineage, you know, from your the target tables you're going to create to maybe raw tables that your, you know, data engineering team is bringing in, or, you know, the shared models that exist in your parent repo, rather than bringing them as models, we also are going to talk about bringing in shared objects that can still be in the parent repo, or I mean, you could build your own in the child repo as well, but you have shared objects that you bring in as sources. And sources are basically, and we'll talk about this, like I said, it's to help you track lineage. You can also add freshness to determine how recently that source was fresh, but we're going to talk about how to set that up to set up lineage and basically use it as an alternative when you're building a parent repo. Rather than having models in your parent repo, have sources in your parent repo, so that you, when you're trying to run a DBT project, you know, a source is not going to run a select statement. Your model, on the other hand, will. So that's kind of what I'm showing in this diagram. We've got Snowflake, and we've got a, you know, the schema and a table name is customer. That raw table, I bring it in as a package, and I only define it as a source. I don't have models and whatnot. And then I can you know, have that in my parent repo, you know, connected to my child repo in my project, or I can just bring that directly into my you know, into my child package and kind of use that in my development. So that's kind of laying out the activities we'll be doing. So in the demo, we're going to do a quick demo, kind of walk through a shared repo, walk through child repo. We're going to walk through a macro in a kind of shared repo and enforce its usage in the child repo. And kind of, we're going to talk about model dependencies and documentation. So let's jump over into my DBT. So as I mentioned, I've got two projects. I've got this one project. It's a DBT project, right? It's a DBT project that I have here, but it is this DBT project. It is connected to the parent repo. So even though I can modify this project, right? And the project is actually over here. This project here is here, and it has kind of some macros in here that I want to use, and it's got some models here that I want to I'm going to call them like shared models that everybody in the team is going to use across teams. So essentially that's what this repo, this repo here is. It's connected to. This project is connected to this repo. So you notice here, I've got like more models here than exists in this repo. For example, adapter test, constraints, Dallas BI. But over here, I've got this Jinja test. I don't think that's in this model. The Jinja test is not here. So that's why it's saying pull changes from remote. I'm going to pull changes from my my Git repository, what I have in here. I'm going to pull those into my project. So I'm going to do, wait a minute. Let me try this again. Okay, so it brought those in, and you notice before there was the Jinja test uh, unit test model here that doesn't exist here anymore. So this particular project, the way I'm going to pull it into my child project is going to be done through packages, right? So when we talk about this option of parent repo and child repos, all we're really talking about are packages, right? So the way you bring in, if you want to connect two projects, the way you do it is via packages. So and the package options, if you want to bring in projects, there's different methods to bring in packages. For example, in our previous discussions, we've talked about bringing in testing packages like DBT expectations. So when we bring in for example, in this case, it's a DBT artifacts package. If I want to bring that in, the DBT artifacts package, all I do is specify the package name, and I specify the version, and settings around if I want to install the pre-release shrew, and I bring that in. But these are kind of already connected. When these are already kind of known packages that are connected. And if I want to, but in my case, what I'm going to do is I'm going to use the option to get packages from Git, right? So I'm using this option here, but all I'm really doing here is pointing to a Git repository, right? So I've got this package here. It's tied to this Git repository, and this is my parent project, right? And I'm going to go into my kind of child project. So I'm going to go in here. So this is now my child project. And in this project, I'm going to go ahead, give it a few to refresh. But basically, I'm gonna write code that takes this DBT test repository I have, and I've got another repository called Dallas BI, which is my child repository. And if I go into macros, I've got some here, but I don't have that generate schema name macro that you see that exists in this other repository, right? If I go into this other repository, this DBT test repository, it has the cents to dollars to generate schema name, but this is my parent one, DBT test, and this child one, it has the swap database, swap table, but it doesn't have those other ones. So what I'm going to do is kind of show how to connect those. And another thing actually I want to show is so even in my child project here, when I want to in my child project here, when I want to bring that parent, the steps we follow is first we go into the packages YAML file, packages.yaml file. And in here, if we saw this example, we go to packages, you type git, and then you give the URL of your git repository. And also DBT kind of highly recommends you give either a revision or a branch name, right? So in my case, I went to my packages.yaml file. I gave the URL of my git repository, right? github.com/consulting DBT test, git, this one. And they highly recommend that you peg that to either a revision or a branch. Otherwise, by default, it's going to be tied to your main branch. So, in my case, my DBT test, I've got a main, QA, and an Ollie branch. I don't have any revisions in here, but I've tied mine to the Ollie branch. So this way, as you're doing change control, and let's say you are kind of testing, let's say there's a new version of a macro you want to put into your parent repo. that macro, you may want to test it into in another branch and do your development there. Because remember, even the parent repo is just another DBT project. You're probably going to have some team that is taking that project and they are working on it. They're adding models or they're adding macros that they determine to be used by the broader team. So and actually we've kind of talked to DBT about having something called like centers of excellence, where when what they recommend and kind of what we've discussed is the one team that's working on the parent repo, they're kind of like the team typically that's kind of training all the other teams on the best way to use DBT. So that parent repo and that parent project is where a lot of that development is happening. Maybe you're testing a new macro that you want to kind of deploy to the team. You're kind of bringing a new model. You want to have it for shared availability across the teams. You would test that, and then you would merge it into the branch that is pegged to your child repos that they're bringing in. So in my case, like I said, I've got it pegged to this Ali branch. But in the development team might be working off the QA branch, or they might be working off a dev branch and merge the changes into Ali branch, or it might just kind of tied back to the main branch. And here, what I'll kind of mention here is that all packages that you bring in are basically essentially other DBT projects. So I don't know if you guys remember, like probably the first session we talked about DBT expectations, right? As a package we want to use. So if I go to the repo for that particular project right here, this is the package for DBT expectation. And all it is, it's another project that somebody has, and it's got docs, it's got like a bunch of macros you can use, right? That, and like math macros, regex macros, or, schema test macros or whatever. So even when we talk about packages that we touch base upon, like testing packages, that the broader community has developed, right? So with the child and parent repo, we're talking about within one organization, right? Like one organization, you've got like a center of excellence department that's teaching the marketing, finance, sales, or whatever, how to use macros. But even within the broader community, right? Me as a vendor, or any vendor out there, for example, this package here, this DBT artifacts, it's developed by a vendor, Brooklyn. It's another vendor that it's an open source package that's there, and anybody can download it. And even those open source packages that are available, like we talked about, that you can do, test creation, like check. I think one of the examples we showed was you can check whether the column you have is a certain data type. Out of the box, DBT can't do that, right? If you want to check, data type of a column and enforce that, okay, this has to be, an int or a string. Or for example, if you want to force that DBT, when you kind of, check in a model, you want to enforce that there's a package associated, not a package, but a test associated with it. There's packages that let you do that. And those packages are essentially, other DBT projects that are out there. So, I wanted to kind of show that even though in the example that we're showing, you're in one organization, and within one organization, you've got a kind of a center of excellence or a kind of a super user team that's creating that parent repo and sharing it with child. The methodology of bringing in projects, bringing in packages, and leveraging the open source community to develop packages and logic for everybody else to use, it's still the methodology of bringing that logic into your environment is still the package, is what we use, right? So I just wanted to and that's like a very, very powerful thing, right? So even, I mean, it's pretty standard, right? If you want to build a package, or you want to build like a macro, you would build it in a DBT project and release it as a package. And that's the same thing we're doing here. We have, we've got macros, but we're not sharing it with the rest of the world, but we're sharing it with just our internal team, but we're still using a package, right? So, and for example, if I go back to, so this is my child repo. I just want to show one thing. Let me go back to my, the project that's tied to my parent repo. If I go to develop there, right? So now this is the project. This Dallas BI project is tied to my parent repo. In that project, I've got other packages that I've also brought in. So I'm bringing in this, the parent repo into my child repo, but even in my parent repo, I've got other projects I'm bringing in. So for example, over here, I've got, DBT date, DBT expectations, DBT util. In here, I'm bringing in the Catalogica DBT expectations, and I'm bringing in version 0.5.1, which is, I've got, they've got different versions here. This is 5.6, but in my example here, I'm bringing 0.5.1. So you notice in this repo, I've got, these packages. And let me go to my child repo now. So my child repo project. And in here, I have got so I already showed you that, to bring a package in, you have to create a packages.yaml file if you don't already have it out of the box, in your project. And you have to, write this logic to bring that in. But just writing it is not enough. Then you have to run something called DBT deps. And when you do DBT deps, this will bring whatever's in this project and in this branch into your project. So this is my parent. I'm going to run DBT deps, and it's going to bring everything in my child project. So I've already ran it, and it's already here. You'll see when I do DBT deps here, it brought in, all the, even though I'm just bringing in my kind of parent project, but the parent project had DBT expectations, and it had DBT utils, and it has DBT date. Because it has those, when I just do DBT deps, it brings in my parent project and all the dependencies associated with it. So you notice here, I've got my models here, and I've got, now these here, they match what's in my repo, and I've got my kind of macros here. So this macro cents to dollars, this exists over here in my kind of parent repo. That still exists here and is brought in as a macro within my child project. So I'm within my child projects, and I can reference this. So another thing that when you're setting up something like this, when you're trying to run macros, when I set this up, one thing I had to do was in my dbt.project configuration, I had to do something called a dispatch function. Now, what it did for, so those of you who aren't familiar with what kind of the order of operations is when you're running a macro, that the first place when you run a macro, there's some macros that are we custom define, and for example, like the cents to dollars, it's a custom one, right? In my kind of child repo, I've got a swap database, swap tables. These are custom macros that I define. But some macros exist in the background inside DBT, right? So one of those macros that exists behind the scenes in DBT is this generate schema name. So even though my kind of purpose, with the function of this particular macro is that when you are running a DBT project or a DBT model, if you have defined a typically you're not going to have like one schema where a model runs, right? So as in this example here, right, I've got a I've got a team A folder and a team B folder, and I've said that for team A, I want team A to run in the team B. It's team A1 I wanted to run the team B schema, and team B2 I want to run in the team A schema, right? So I've defined custom schemas here. So when you define a custom schema inside DBT, the default functionality that DBT has is that it appends something in front of it from your default schema, right? So if we look at, let me go and actually do custom schema, using custom schemas in DBT. The logic that out of the box DBT applies is, if a custom schema name is not given, right? So this is a custom schema name. I'm telling it to use a custom schema here. That's what I mean when I say the custom schema name over here. So it's saying that if the custom schema is not defined, use a default schema, right? So in our case, the default schema is whatever we defined when we set up the project, right? Which in our case, it's not this, right? So it uses, if there's no custom schema name, it uses this. But if there is a custom schema name, or basically else, any other condition, the DBT out of the box assigns a default schema plus the custom schema, right? So the custom schema is here, right? The default schema for this project is going to be, if we go into account settings and we go into test DBT, and we go into the connection, this has the compute warehouse. We have to go here into the profile. The default, the custom schema is team A, right? So if I run that DBT project out of the box, if I go back here, if I run this particular model in team A1, it's going to take the team B here, which is my custom schema, which I've got here, and it's going to append a default schema in front of it, which most shops that are running it, you don't want that, right? Like, especially if you're most organizations, they have a kind of a naming convention, or they have a configuration of how they want to enforce, or the naming conventions of how they want schemas to be created. And when you append like a default schema to a custom schema, this doesn't work for most organizations. So most organizations, the default behavior of how a schema is written, they want to override it, right? So, which is what the macro that I developed in the parent repo is trying to do. So in my parent repo, the macro that I have in my parent repo is basically saying that, if there is no custom schema, right, then use the default schema, which is fine. Everything will work. Else, use the custom schema name, right? So it's saying otherwise, use the schema name that I've defined here, right? The schema in my project.yaml file, dbt project.yaml file. Now, it's a very simple thing. This is not like earth-shattering or anything, but because, and this is just one example, but because it's something every team will use, you know, because probably most teams, they will have like a standard naming convention. It's a good candidate to put as a, you know, as a shared macro that all the teams can use. So that's why this was the one I used for this example. And so in this case, since I have that as a you know, as a shared macro, you notice in this case, I have it as give me a second here. I have it. Go back to the project YAML. I have this dispatch function. This is what I was talking about, right? The dispatch function where I have the order of operations. By default, DBT is going to use the name that's in. There's a DBT namespace, which we don't see here. By default, DBT uses that particular namespace. I'm saying that when you have something, when you have a name that matches what's in the DBT namespace, don't use that. Basically, use my parent, use the parent my new project, which is basically the name of this, the name of my package. I'm saying whenever you get to that, to the generate schema names, instead of using what's in the DBT, you know, use what's in the parent my new project. Or what if that name is not there, then use, you know, my new project, which is my this child project here that I'm working with. Otherwise, use the default name of that particular using the default value of that macro that exists in the DBT macro namespace. So I think in this particular case, so that's one thing I wanted to show here. The other thing I wanted to show in here was, for example, I've got this in my, actually, did that make sense? For example, Russ, I think you're logged in. Did that piece make sense of how we're kind of forcing the
my main question is where how the schema fits into everything. So I've got a specific idea from SQL, and otherwise I think what you've done, it makes sense.
How schema fits into everything? What do you mean by that?
What do you mean by schema?
Oh, schema, it's basically my schema in Snowflake, right?
Okay.
So
that's where I was missing.
Yeah. Okay. So basically I've got schemas here in Snowflake, and that's what I'm referring to here. That, you know, I'm in here, I've got custom schemas, and I want this to be the schema name that I defined for this folder, right? And I'm basically telling it that either you know, use the logic in my parent project, or you know, for this to pick up how to assign schema names, right? Where you know, where I'm saying if a custom schema name is defined, just use the custom schema name. Don't append anything like the default functionality of DBT does, right?
Okay, so it's going to use whatever the first macro it finds in that order. So it'll try.
It's going to use the first macro that it finds in the namespace.
Yeah, so it's our parent. If it doesn't exist in parent my new project, goes my new project. If it doesn't exist there, go to DBT. Okay, which is
that goes into DBT. Yes, exactly. And I think one thing I have in here that I want, because I'm so see, I've called it generate schema name, right? That's the name of my macro. right? And I'm saying that whenever generate schema name exists, it's a name that exists in the DBT namespace. Like, don't use that. Use my parent. Otherwise, use the child project. And the last thing is use a DBT namespace. One thing that I think you have to have is if generate schema name is if generate schema name is my macro, right? And I want, but that macro, I want it to use the version in another namespace that's not in the DBT namespace. I have to write a default underscore underscore in front of it. And so this default underscore underscore tells it that, hey, this is one of the default macros that exists, right? In the DBT namespace. You have to use this version instead. Don't use the default, use this version. And let me go to the dispatch, DBT function here, because the function, this function can do many things, right? Like if I've got macros that are specific to a certain data source, right? I can append Postgres underscore underscore. And if I've got the same project, my project is tied to Snowflake, right? This project is tied to Snowflake, right? But if I have a project that's tied to, say, Postgres or Redshift or BigQuery, I can have the same macro logic, but it could be defined differently. I could have one macro to run on Postgres, the same name, right? The same generate schema name macro. I could have one version that runs on Postgres, right? All I have to do is append Postgres underscore underscore to this macro name. And that's what, if you're in Postgres, it'll run this macro. Does that make sense?
Yes.
Yeah. But in our case, we're using the default. Like I'm saying that, wherever you have this macro, it's a default macro in the DBT namespace, use this version in my parent project. So that's one thing I wanted to call. I just noticed that I had not saved that piece. So if I had run a model, if I had run the model, it would not have. Well, actually, so another thing here. So you notice I was trying to change. See, I'm in my child project, right? And in the child project, I'm trying to change the package that's connected to my parent repo, right? I just tried to do that here. It let me save it here, right? But this is not what's in the parent repo, right? If I go to the parent repo, what I have there is in the parent repo, it just has the generate schema name. It doesn't have the default underscore underscore, right? But I just changed it to default underscore underscore. But I'm working in the child project right now, right? So every time, if I do DBT deps right now, and I do enter from my child project, it should overwrite this default underscore underscore, and it should pull whatever is in the Git repository tied to that branch, right? So it's kind of running through the dependencies. If I do this again, the DBT deps, I'm in my parent, right? So if let me actually close it and reopen it. If I close it and I reopen it, yeah, it's got the generate schema name. It didn't preserve that that default underscore underscore I did here. I will have to go, into my Git repo that, or a project that's tied to this Git repo, and update that to default __ to make it work. So let me do that here. Underscore. Let me commit my changes. And then let me do a DBT depths here again. I'll run all my dependencies. So it's checking all the dependencies. It's bringing in, you know, from that Git has Ollie branch, but notice in the Ollie branch, I have DBT expectations, and DBT expectations have dependencies on DBT utils and DBT date. So it'll bring all the dependencies when I do it. So now if I do it again, we close this and open it. Let me refresh.
You don't have to get the most current value, do you? Or...
Did it already do the DBT depths? So over here, I did the generate schema name. I did default. Oh, I did it in main.
I was going to say that I noticed that. It should go to Ollie branch. Okay.
Yeah, I need to do it in the Ollie branch. So that's, I didn't capture that. I got to do it in here. And let me make changes here. Now let me do DBT depths. So accept those. Let me do that again.
So when you run that command, it's actually going to go out and refresh from.
Yes, it's going to overwrite everything that you have. You know, you may have changed things and you think it's saved, but when you do DBT depths, it's going to go to that Git repo and bring everything back, whatever's pegged to that version or that branch. Let's check it now. Let me close it and open it. Oh, it's gonna. So now it's got the default in here, right? So that's one thing I wanted to show. So if we have, so another thing I wanted to show was the model dependencies. So you know, the thing with DBT that's, you know, really neat is that it builds the DAGs and it's got the, you know, model dependencies from you know, whenever you use the ref function, right? So I've got a table here. I'm using so I've got a table in my child repository, you know, this table A1, but I'm referencing a table named, a model named A that exists in my parent repository here, right? So I know that a lot of teams, like the question that came up when like we're evaluating DBT is like, hey, if I've got kind of these shared projects, right, and that are going to have models in there that are, you know, are meant for the entire team, what happens to data lineage, right? If I have a model in the parent repo, how can I reference that in my child repos? Because, you know, people like the DAG, right? Like they like the DAG feature that, you know, as long as I use a ref in here and I go to lineage, it tells me, hey, I might use like 10 reference to 10 models that exist, right? It'll build a DAG based on those. But if I got something in the parent repo, you know, that's not in my individual team repo, the functionality with bringing in the packages, you know, it lets you build the DAGs as well. So I'm referencing, you know, table A here, right? That's in my parent repo, right? And because, and I'm just using a simple union, but because it's part of the project now, even though it's in a totally different repository, it's a totally different team working on it, but the fact that it's part of it, it is gonna show me that dependency, which was, you know, when you're building teams that are going to use kind of shared objects, this feature comes in very handy. So I'll do a run here. So table A1. So I'll run this, and then this should bring everything together, because this table A1 is actually supposed to run against in team B schema. You notice I don't have a team B schema here in my DBT, in my dev. I've got a raw, stage, and a Z final. I don't have a team B schema. If this was using the kind of standard functionality, it would have taken the team B schema and a team A schema and appended it. When I run this DBT run select table A1, it should only run it in the team B. It should create a new schema called team B, and that's all it should run, right? And it table A1, it unions a bunch of names, my name and a couple other names, and then it unions from ref A. So if I run this, which is basically, it's gonna run everything twice. I've got the same information in here. So if I run it right now, well, actually, it's probably it might fail because I don't think I have a table A in here. Yeah, because I don't have authorized. Okay, I think the thing is that model A doesn't exist, so I probably need to run that first. So even though the DAG references that, but it's saying that particular model, it does not exist there. So that's why it gave the error. Does that make sense?
Yeah.
Because the table A doesn't exist anywhere here, right? In raw and in stage or final, it doesn't exist anywhere. So that's what it's complaining about. So let me run A first. Okay, so it created that. It created it in team A.A. So there should be a new schema here called, team A.A. So in the previous run, I think it created a team B, but I didn't populate anything in the team B because it couldn't find this A table A, right? So if I run again, the team A1, right? So select A, the table A was in the parent project. So it ran that, right? Even though it ran that SQL, it ran that SQL in my Snowflake instance. And then now I'm going to run team, actually it's table A1. I'm going to run like table A1, because now it has the A table there. This should run just fine, and it should create it in the team B schema. It shouldn't append anything. Yeah, so it created table A1 and it created in the team B schema. So it didn't apply this logic of default schema name. If we refresh it here, it created this table A1 with 8 rows. This has 4 rows. That table A, it basically joined it to itself and created 8 rows. So in this particular case, one thing I mentioned with the sources, that you may not want the users to be able to run the objects that are in your parent package from the child package, right? Like this table A, right? It could be the customer table, and there's already a table there that's pre-run, right? I don't want my marketing team to rerun my customer table, right? The logic for it. It's already run, it's already there, right? If you, in your parent project, if you bring in the models like I have, you bring in the SQL, the bet of the models. That's a good thing, right? Because if the users that are working in the individual team repos that have issues with their particular projects or the defined tests based on what's in the parent repo, if something goes wrong, they can look at the SQL statement up here, right? In the from the parent kind of shared dimensions, and they can say that, oh, this is the SQL, I'm referring this, or I'm joining on this column, it didn't work, or my error, I got an error. Oh, that's why, right? You have the SQL to do traceability, right? But once again, with that, there's other ways I'm still kind of playing around with where you can exclude running stuff in the parent repo, right? And just make the people that are in the child repo what's in the child repo. But you know, it's something called I believe it's called YAML selectors, but it's something I'm still not completely sure of. But one option that drawback that doesn't give you the SQL is using sources, right? So I've got you know, this in my child repo, I defined a source where I created a new YAML file called define source. The name can be whatever, but in that source, I defined a source name, you know, the sample source. I give it a description, and then I can give a database schema and a table name, right? So in my Snowflake, you know, like how we have the AdventureWorks in SQL Server, you know, there is a Snowflake sample database, and within that, I believe it's this one, there's a call center table that they give you with a you know, data you can kind of play around with. I made this call center table a source in here, right? And I gave it you know, a description here. Now this source is now available to me as an object to reference. Just like we use the ref function, right? In here, I use the ref function to reference a model that exists in the parent, or you know, even you can use a ref function anywhere. I have another source where I have a test source model, and I'm using it to use that call center table using this source function. Does that make sense? So I'm saying, yeah, select star from this source, right? And I'm giving the source name and then the name of the table, which is defined here. And which is defined in the source. So I can basically, if I want data lineage, you know, in my projects, you know, where I have stuff created in the shared repo, but I want to share it across the child repo, I can just bring in the models. I can do YAML selectors, which I haven't shown here. I'm still working on that. And the third thing is using this test source option. This source, defining sources and refer to those. Even if you don't want to do it for like your, you know, parent child repos, right? Where you've got shared model, like a customer dimension or whatever. For your data engineering team, if they're bringing in raw data, right? Like different flat files they're bringing into Snowflake, for example. And if you want lineage all the way back to that raw data, you can do that with sources, right? So you get like a complete mapping. It doesn't just have to be your objects that you've done some SQL on and you've created, right? It could be right back to the source table that whatever the staging data that your data engineering teams bring back. It's totally possible. I'm not sure if that level of lineage everybody would let's put it this way, it's possible, right? Like, do you want to spend the time to define lineage that far back? It's probably not a bad idea, right? You know, if you wanna set that up, but that is possible to do, right? So in this case, when I'm showing the test source, and if I do the lineage, you'll see it shows that DAG, right? It shows that source, and it's saying the test source is my model, and it's the source is this call center. And if I like let's say I do compile SQL. If I compile the SQL, so it's not running the SQL, it's just compiling it. Basically, it takes that sample and it converts it into the database name, schema name, and the table name, right? And if I preview the results, it's just gonna run that query, right? So, you know, it's running that call center query. So the last thing with all this, you know, that kind of our teams really got excited about when using DBT was the documentation functionality, right? Because I've got all, so when we're creating DBT models, you know, we can define tests on them. We can write out, you know, within DBT and YAML files, we can write out descriptions for the models. We can write out descriptions for the column names. You know, we've got tests. You know, we've got right here. We showed sources and these DAGs that are associated with it. And because you've got your parent project and your child project, and there's connectivity, and you want to see that like in one location, all the artifacts for your project, that's something that comes in handy a lot. And as I mentioned in my slide deck, in the security architecture, your business users, right? The read-only licenses, right, that we mentioned. Some people, they don't really care about your SQL. It's just about maybe business analyst, or you're writing an extract, or you want to give documentation to some team. Hey, we wrote this extract. They want to know, what are the columns, what are the fields, what are the descriptions? Rather than, you know, if you've defined that documentation in these YAML files, you can give them read-only licenses to your DBT. And granted, you have to manually go in and fill this stuff out, right? But if you do that in DBT, then you can look at the documentation, right? And all the relationships there. So to do the documentation, there's two steps. First is DBT docs generate. This basically generates your document. And let me run this. And then there is first it generates the document. So you notice it's doing it for the whole project, everything that's in my kind of parent repo and in my child repo. And then you can do, I think it is forgot to come up. DBT docs generate. See, first it wasn't working because it's the docs does the generation, and then you have to do DBT docs serve is the other command. This will actually create it'll create like a web page that gives you all the documentation in your project. So I already had one up here that was already done. But since I made some changes, I'll click it over here and it'll create a new one. I already had this one created, but I'll just do a fresh one. And here you'll see my parent project with my model. You know, I've got this model here. I can look at the details of the model, the descriptions, you know, the columns that I have, the SQL that I have. I mean, it's basically, it's just one page. And then if I go at the bottom in my project, you notice I had this table A. It had dependence from dependency on table A. See, I can see that here. You know, I've got the table A the things that it's dependent on. They're defined over here, and I can see that dependency here. So I think if I go up here, if I go in the database, so it gives the database from the schema. It reads kind of where all my objects are going to be. It also gives, see here, see this is, yeah, see this is my DAG. So I can also go in, if I go into this, I'll show that, hey, this is my table A. It's dependent on, sorry, this is my table A1. It's dependent on table A from my shared repo. And also it has a test associated with it called fail A that, that's going to check something. And I think this fail A test that I have, it's just a SQL statement here. Basically, you can write SQL tests that say that, if the SQL statement returns a result, that test has failed. So it's basically showing that, hey, this particular test, this fail A exists for table A1. And so in one location, you're able to see, pretty much, everything, about your project, from your shared repo to your parent repo. And, that's when you're talking about deploying across, multiple projects. Maybe you have, dozens of projects, dozens of different teams, each have their own projects, right? You cannot work in one project, right? Because it's going to get too unwieldy. Not all the teams, 20 teams can work in one project. And you don't want them working in all separate projects either, because like I said, there's macros and objects you want to share. So this option with the parent and child repo, where you got, it gives you some semblance of a shared field, shared macros, shared objects that every team can use. You can view documentation and dependencies. And it also gives each individual team ability to kind of manage their own project, right? Because we talked about the security architecture, where, if a team is running their particular project, they have their own project admin. They manage their own projects, they manage their own Git, own team, own database, own developers, they're managing that. So it gives you some multi-tenancy where, the kind of the center of excellence, or the kind of the super user team that creates the parent repo, they can create some objects and then they give it to the individual team members, and the individual team members can kind of suck that in using packages and from that parent Git, and they can work in their project, independently of other teams. So, that's kind of what we wanted to show here. And I think that's about it. Any questions?
No questions at this point.
Okay.
This is my first exposure to this, so.
Oh, this is your first exposure. I thought you had been to another.
No, I hadn't.
Oh, no, you hadn't. Okay. Got it. Okay. No, I hope this was helpful, because typically I ask if you want me to go from the beginning, like where I create a project, I create a model, I materialize it. I just skipped that piece because I thought I had seen you in another session.
I might have missed it, or might have slept through it. I was probably working on something at that time.
Okay. No, well, I hope this was helpful. Maybe it was a little bit too advanced. Yeah.
Well, it's helpful to see what it can do. So does this work then? I see you have it with Snowflake, but other database products?
Yes, it does.
Okay.
When you created, I think, like I showed, Postgres, Redshift, BigQuery, Snowflake, obviously, and I think those are the default ones that I've seen it connect to.
Okay.
Like when you create a new project, that's the option it gives you. Like if I go in here, account settings, and I go to new project, begin. I give test. It'll give me these options. Databricks, Apache Spark, Snowflake, BigQuery, Redshift. Yeah. So I don't see like Synapse or SQL Server or anything in here. So I know a lot of it. They have a really tight integration with Snowflake and Databricks.
Okay.
I know. I think they might be even investors in DBT. So I know that Snowflake, a lot of people use it with Snowflake. Yeah, Snowflake doesn't really have its own ETL tool, right?
Oh, okay.
So It's a very common use case with DBT with Snowflake.
Okay. Okay.
Yeah.
But you can't, it does integrate with Databricks.
Yeah.
I wonder if Apache Spark would work with Synapse or not.
Yeah, I haven't tested that. Like if you have an Apache Spark table, like a Spark table or
Right.
a Spark
Okay.
environment, like a Spark pool in Synapse,
Right.
can you connect that and tables you create there and objects you create there, bring those in and modify those and write back to Synapse Spark pool.
Okay.
Maybe you could do that because it doesn't say Synapse, but Synapse Spark pools are just Spark pools. It's Spark at the end of the day, right?
Yeah,
so
it
you got a
is.
Spark pool. You got a Spark a pool running. I haven't tested that.
Okay.
It's an interesting topic to do. Apache Spark and Synapse.
Okay. Okay, so the developer license is free for one seat,
Yes.
but as soon as you put a team together, you're looking at 50 per seat per month. Okay.
And what ends up happening is, with the team, then if you have multiple teams, you can work on one project together, right? But technically, like if I gave you the Git repo, right? I would give you the ability to connect to that Git repo that I have and bring it in. You could create a brand new project, like a Rust project. And you can bring that Git repo, both the child and the parent, as long as you can connect to my Git repo, you can have a developer license running totally independently, right? And you can work on that project using the developer license.
Right.
So it is possible. The problem is when you get into things like environments, right? So my project, right, this DBT Dallas project, test DBT project, for example, you have things called environments, right? That when you want to schedule jobs, that's something pretty neat, you can like I've got a development and a prod environment, right? And in the prod environment, I can schedule a run, and I can schedule a job that's tied to that environment, right? So in that environment that I create, it has prod credentials, right? And it's got prod setup, right? I can run that same Git repo. I can point this environment to a branch, right? Mm-hmm. And I can run jobs against it, right? But if I've got an environment running, you have your own project, you cannot see my environment. And if I did like 10 runs, you won't be able to see them. That's where the team comes in, right? So you can connect to my Git and work on it independently in a free developer license. But if you want to see the environments that I have and the jobs I've run, you won't be able to see that, right? So, it's an admin feature, right? But because you can just go into your own development environment, right? And just execute DBT runs in this IDE, right? In this GUI environment, right? And it'll run projects for you. But if you want to schedule them, that's where those jobs and those environments come in, right? And if I've scheduled some stuff and you won't be able to see them.
Okay.
Right. But another thing within jobs, I've got a table A, table B. If I go to settings, see, you've got like webhooks. I mean, they work, but this API option, this is not for developer accounts, right?
Okay.
If you got to have the enterprise license to do this, even the teams won't work. Okay. So if you want to, let's say your ETL runs in like Data Factory, Informatica, or whatever, once it runs, you want to call DBT to run its thing, right? Yeah. You would use the API functionality, but that's only for the enterprise licenses. Okay. So, that's where the license comes into play. And also that security architecture I went through, this is only applicable for enterprise license. For developer, it doesn't. It's just you, right? Right. Okay. Well, cool. I hope that was helpful.
It was just a different way of looking at the process. So
Yeah.
might look into it,
Yeah.
especially since it's a free developer.
Yeah, I've got other videos, you know, if you want, I can share those with you on my YouTube channel that have the intro version. I've done, this is our third event on DBT. I've got one where it's just intro, where I just go through the project setup, you know, basically, you know, go in here and actually, you know, create a project from scratch and connect it to DBT, you know,
Okay.
like a TST here. I do Snowflake, and then this screen comes up, and like I go through, hey, what do you need to get from the account? You know, it's basically, you know, this thing you got to paste in there and enter your credentials and what this all this screen means. I have a video that goes through all that, and also have a video that goes deeper into the Git repository, those environments and jobs that I talked about. I've got one that goes into macros a little bit. But then this one was just about this is definitely an advanced topic, because most teams, if you've got just a couple of people, you know, working, if you're a small shop, you won't care about, you know, multi-tenancy and shared packages and all this stuff. This is unique to like large clients, right?
Okay, right.
Yeah. So yes, this is definitely more on the advanced side.
Oh dear. Let's see. Trying to find your videos.
Oh, you're on the channel?
Trying to. I'm not.
Yeah. Go to here. Go in here. Give me a second here. Okay. Sorry, let me. I'll post it in the chat. My channel info in the chat. And post it here. And I've got a couple of videos on there on DBT. Some on like ADF, Azure, and
Okay.
other topics, but there's some specifically on DBT.
Okay. Well, thank you.
Yeah, hopefully that helps. If you've got more questions, it's definitely a new tool. You know, different ideas or topics you wanna go deeper into, let me know.
Okay. So DBT videos.
Yeah,
Let me just put a reminder to look at it.
of course. Of course. Let me stop the recording here.